Welcome to the Fundamentals of Testing AI webinar. I'm Simon Knight, the product manager here at Testmo, also testing evangelist, and I'm really glad you could join us today. If you've been following Testmo's recent blog series, then you'll know that we've been exploring what it actually means to test AI-powered features. During the webinar today, I'm going to cover very similar ground, but with the benefit of our own in-house testing practitioner, Nataliia Chutchenko. Nataliia works with us here at SEMBI and has been instrumental in the design and implementation of some of our own AI testing approaches. So I'll be digging into her experiences by way of an interview in a few minutes' time. Before we get into the interview itself, I'll briefly cover some of the points from the recent article series in terms of AI testing strategy and how to turn some of those strategies into actions with sort of specific practices or heuristics. That'll segue nicely into the conversation with Natalie around her experiences of applied AI testing. And after that, we'll dive into some Q&A. And after we've had some questions, I'll kind of finish things off with some thoughts about how to use Testmo for some of that AI testing for AI evaluations specifically. So just to mention for housekeeping purposes that for Q&A, we'll be taking questions via the Zoom chat, via the kind of Q&A console in Zoom, which hopefully you've got access to in your respective Zooms. Please feel free to start dropping questions in there as you think of them, and we'll try to make sure we choose some good ones for the Q&A segment. As I mentioned, I'm Simon Knight, Testmo PM and Testing Evangelist, and we will be joined shortly by Nataliia Chutchenko, who is our in-house QE and AI testing practitioner. So looking forward to that. Just going into the sort of main presentation itself, then in our recent user survey, we asked users the question, are you responsible for testing any AI features in your products? And our respondents said mostly no. Around 70% of our respondents replied that no, they're not currently responsible for testing AI features, which we thought was interesting. But around a third of them, so 31%, as it says here, are responsible for testing AI features, and that number is likely growing. We'll check back again next year and let you know. But I mean, I recall going to a Eurostar conference a few years back when hardly anybody was really involved in AI testing. The only presentation around AI testing was focused on AI models for self-driving cars, and it was a super interesting presentation, particularly in terms of the model development aspect, but it was very niche. That was back in 2022, and if you fast forward 3 years, AI is everywhere. I mean, you can't seem to get away from it, right? So I made kind of a throwaway comment in our first article around AI sort of creeping into our products like Borg nanoprobes, and I've kind of lent into that sci-fi trope a little bit more with this particular slide. Hopefully I'm on somewhat safe ground there with this audience. And I guess my point is that AI features are, popping up everywhere, and they're quickly becoming mission critical in terms of how those things are implemented into product feature sets. So you've got things like co-pilots, chatbots, smart schedulers, content generation, assistants, I mean, all kinds of things, and they're everywhere. And as QA professionals, we can't ignore it. We have to adapt to the changes of AI testing and tailor our testing approaches accordingly. And there's some challenges with how we actually do that, right? With how AI is tested versus, what's gone before and how we've tested other systems, products, applications, software, etc. So, as I said, AI features creeping into products like Borg nanoprobes. Determinism is gone, right? In traditional systems, if you put the same input, you're going to get the same output. But in AI, the model temperature, the model version, the specifics around prompt wording, all of those things can change the results that you may get out of your AI system. Failure modes are invisible. So something like a REST API, for example, might give you a 500 error when it breaks, whereas an AI will, quite confidently sit back and tell you that, Paris is the capital of Italy or something. The system evolves without code changes. So, things like models drifting, the data that's being used with the model changing over the course of time, user behaviors and expectations of how they interact with given models, thinking about um, how people interact with tools like ChatGPT or Claude have changed over the course of time, and expectations have changed as a result. All of those things can degrade, the user's perception of quality of that experience, right? So testing AI requires a shift, not just in tools, but also in terms of your mindset, your approach to testing it. The QA mindset has to evolve from asserting quality, whether it passes or fails, expected versus actual results, to evaluating performance and measuring quality across dimensions. Um, Ultimately, rolling with and adapting to the changes that those AI technologies are bringing about. Resistance is futile. So just zooming out for a few moments to the sort of strategic or the Skynet prevention level. When I wrote and when we published 10 essential practices for testing AI systems in 2025, as the article was called, the goal wasn't to create yet another listicle. It was to kind of carry out a literature survey of what the best teams are doing in the wild to assess the performance of their AI systems. So, as an ex-tester myself turned product manager, responsible for the implementation of new AI features in our own systems, I wanted to kind of understand the lay of the land and see, what the sort of bleeding edge of AI system developers were thinking and doing about the testing of those systems. So obviously, I'd encourage you to go and read the article yourselves, but ultimately, I arrived at a list of 10 practices. So those were trust, risk, and security management. So testing for trustworthiness, traceability, ethical behavior, things like that, right from the outset. Red teaming and security testing, examining whether the AI can be exploited through prompt injection, jailbreaks, or other attack vectors. Data privacy and protection. So, kind of going beyond just compliance, taking into account the fact that AI models can leak training data or leak sensitive information potentially through sort of clever prompting. Explainability and transparency, testing to ensure you can explain why your AI made a decision, which can be especially important in regulated or other sensitive environments. AI governance and compliance, validating audit trails, versioning, rollback procedures, stuff like that. Human in the loop testing to ensure that users can flag, pause, or override AI decisions if needed. Advanced testing for non-deterministic systems, so testing to help validate the relationship between inputs and outputs, taking into account that they probably won't match in different executions on any given test run. Data quality, diversity, and bias testing. So making sure your AI performs equally well across different demographics, languages, and contexts. Model lifecycle management or model ops, which is basically continuous integration and continuous delivery for AI, helping to ensure that your model is built consistently and versioned appropriately. And finally, continuous monitoring and improvement. So, doing things like monitoring for drift from the sort of current operating context, validating your alerting systems in the event that, that drift does actually occur, and feeding failures and learnings from those things back into your testing suite. Clearly, that is a lot to think about. And, as a tester, responding to some of the ideas in that initial article, I was looking at it and thinking, well, where are people actually going to start? And that's, kind of when we decided that actually we should probably do a couple of follow-up articles to that. And, the sort of the concept for the follow-up was basically going to be that although obviously there's a lot of advanced testing practices in this list, ultimately testing AI systems requires the same basic mindset that professional testers have always had. Things like curiosity, systems thinking, user advocacy. Testers have always had empathy for users. They understand the needs of the business. They're well versed in applying a testing approach systematically. They just need to bring those existing skills to the table with this new technology. So with that in mind, you kind of end up at a sort of condensed set of heuristics for testing AI systems. So defining quality early, deciding what good looks like before you start building them from the outset. So, this shouldn't be anything new. This is requirements testing, kind of 101. Testing for bias and fairness. Don't assume that the underlying training set is neutral. It probably isn't. Validating data quality. So, garbage in, garbage out, but multiply it by 10. Keeping humans in the loop, I already mentioned. Reproducibility and versioning, so making sure every model, prompt, score is traceability. Continuous evaluation, because the system never stops changing. Stress testing prompts and guardrails, what happens when someone tries to break it. And transparent reporting, bringing visibility to non-deterministic quality. So, the goal here was to present some ideas. Well, not so much ideas, but actionable steps that people could start to implement straight away. Um, To put things another way, you don't need to become an AI expert to test AI features. As I've talked about a little bit on the previous slide, and as I'm trying to kind of indicate on this slide, there's a shared foundation between deterministic and probabilistic testing, and testers already have a lot of the necessary core skills. They're already experts in risk-based thinking. Testers naturally ask, what could go wrong? What happens if I push this button instead of the other one? That kind of stuff. Testers love to explore and exercise curiosity. Testers are systems thinkers. You don't look at things in isolation. You're looking at things from a sort of systems view, integration points, end-to-end flows, threats to value, security, integrity, that kind of stuff. And empathy for users, continually thinking about what the end user experience looks like and keeping quality in at front and center in terms of your context, your domain. So this is like by no means an exclusive list. There's obviously lots of other attributes that we could add. I'm just kind of pointing out here that testers already have a strong skill set and a lot of overlap with the expert practices that I mentioned a couple of slides back. The same skills apply to AI testing. You're just putting different objects under the microscope, so to speak. So, stretching that concept just a little bit further, we can go as far as to say that when testing AI, our heuristics kind of shift, our focus shifts a little bit from does this meet the requirement to does this meet the intent instead. And in the sort of second article that we released on this topic, we kind of identified some guiding principles for making that shift. We've already spoken to some of them. So starting with risk, identifying where the biggest potential harm lies, mapping the system, looking for input channels, data flows, and failure modes, using exploration and curiosity strategically. A lot of AI testing is exploratory in nature. Collaborating early, taking a shared responsibility view of what's being developed and how it's going to be tested. And then identifying and figuring out how to measure quality dimensions or evaluations, thinking about completeness, clarity, factual precision. So identifying measurements for how you're going to test your AI system. So, kind of summarizing the AI testing mindset in sort of one sentence, shift from proving correctness to measuring quality. And probably this isn't like a huge leap, particularly for testers with more of an exploratory testing mindset, who don't accept that every test should have like a binary pass-fail outcome. How does that actually work in practice, though? Well, that segues hopefully quite nicely into our conversation with Natalie. Are you there, Natalie?
Yes, yes. Hi. Uh,
Hi, Natalie.
can you hear me?
Yes. Can't see you right now. There
One
you are,
moment. Hello.
Natalie. Welcome.
Hello, Simon. Hello, everyone. It's a pleasure to be here with you today.
Thank you so much for joining us, Natalie. So, just I guess following on from some of the things that I've already been talking about, do you want to just like introduce yourself and tell us a little bit about what you've been working on and how you started to think about your testing approach to it?
Yeah, so I'm a QA engineer, and our team was involved into the project, which included the integration of LLM into our product, and also the evaluation of LLM. In general, the aim of our product was to integrate the LLM. Of our project was to integrate the LLM to give our users the possibility to increase test coverage, for example, to save time, to increase their productivity due to using the content generated by LLM in response to their realistic prompts. In our context, in our case, evaluating the LLM under our project was a kind of an assessing the assistant for the QA teams, which will help them to generate a qualitative content and to augment their QA manual work. Yeah, so in general, we had 5 LLMs to be evaluated, and we had to choose the best one to be integrated into the product. So we had to so our first aim was to assess the LLM, to define their limits and capabilities, and for the integration of the model, not to become a kind of debugging for the AI for us. Yeah, so yeah.
So, you were integrating an AI model with an existing product, is that correct?
Yeah, correct.
Part of the challenge was figuring out what the right or the more preferred model was to actually integrate, right? So you had a couple of models that you could choose from, and you needed to try and figure out which one was best. Is that
Yeah, exactly.
so?
And yeah.
Sorry, go on.
Um, uh, well, that's actually it regarding the aim of our product, and actually the like regarding the activities that we performed. Um,
So how did
yeah.
you actually go about evaluating which model was best suited for the specific application that you were seeking to use it for?
Yeah. So we had a kind of a 5-star rating system. We had a framework for evaluation, and we used a kind of a 5-star rating system, according to which we evaluated a minimum viable quality metrics for the LLM, which included coverage, relevance, clarity, actionability, duplication, and also latency. So just in short, for the coverage, we looked for the LLM to generate the content that would cover the key requirements of the prompt, including, for example, negative scenarios, positive scenarios, some destructive scenarios, and so on. For the relevance, we looked for the LLM to generate the content which would be aligned to the scope of the requirements. What concerns duplication, we looked for the unique content to be generated by the LLM. Also, clarity, which for us meant if the generated content is easy to understand, and also the actionability, which in our case was if we could use the generated content readily in our products flow. That is, if we could include this content without making any changes into runs, for example, and so on and so forth. And also latency was measured, was checked. That is the time it took the LLM to respond to the prompt. So with our 5-star, or let's say 5-point system, we also used a color scheme for marking the content generated. For example, we used a green color to mark additional relevant scenarios or like items of content generated, which added to the coverage. Also, with the blue color, we marked the scenarios which, like, they were relevant. They were covering the requirements, but like the requirements were misunderstood in this case. With the orange color, we marked duplications, for example, and with the red color, we marked hallucinations, some deviations from the requirements that were clearly stated. Yeah, so as for example, as a practical example, let's say we got 25 items of generated content, and we have to give the score to, let's say, coverage metrics. And we see that 20 content items are strictly covering the requirements we send to the LLM, and one content item is just like is marked green because it's like a valid additional scenario. So it's 21 out of 25, which makes 84% for like for the coverage, which in our case meant for 4 stars or 4 points.
Okay, so I think what you've said is basically you identified different dimensions for the test for the test cases, let's say that you wanted to perform in order to evaluate the different AI models. And you used like a 5-star rating across those different measurements or the criteria that you wanted to measure. Coverage, what was the criteria again? Can you repeat those for us?
Coverage, relevance, duplication, that is the uniqueness rate, also clarity, actionability, and latency.
So there were 6 measurements
yeah.
in total. Yeah. And you use those to test 2 different models. How did you actually arrive at those specific dimensions, the criteria that you were going to use for your testing purposes? Can you tell us a little bit about what that process looked like?
Those criteria actually they correlate with the traditional QA, let's say metrics. For example, coverage corresponds to, let's say, traceability metrics or test coverage. Uh, uh, then duplication, let's say, corresponds to test overlapping or redundant testing. Clarity can correspond to, let's say, completeness of the test case. So we use those criteria, those rubrics, just to make the evaluation more like closer to the real life traditional QA metrics.
Got it.
Like, because
So,
as I said, we were a kind of evaluating the QA assistant.
got it. Yeah, yeah, that makes sense. So, in the context of what it was that you were testing, you wanted to make sure that the generated AI output traced directly back to the sort of input, the requirements that you were putting into it, and that there was no duplication in the output, for example. That was one of the specific metrics, right? Or
Yeah, uh,
rubrics, right?
exactly. Um, exactly. Also, um, uh, it was a kind of a plus for the LLM that it could generate some additional relevant scenarios or relevant content, not just merely covering all the requirement items or prompt items, but adding some meaningful data.
Got it. So I'm just keeping an eye on the Q&A panel in Zoom here, and I can see that we're already getting some quite interesting questions from the attendees. So what I'm going to do, I think, is just start to jump into some of those as part of a kind of ad hoc Q&A session. And then maybe we'll go back to some of my questions after that as we start to wrap things up a little bit. Is that okay with you, Nataliia?
Yeah, sure.
So let's go to this one from David Nash. So when testing AI, if the expected behavior does not meet the actual behavior exactly, have you used an independent AI model to automatically decide whether the difference is acceptable? Um, I
Mm,
guess sort of making that question a little bit broader. Um, there's sort of two questions in there that I might ask. Did you use AI to verify the AI output at all? So I think that's what David Nash is asking. Or how else did you identify whether or not the differences between your sort of expectations and the actual results were acceptable? And are you able to provide any kind of examples?
Actually, we didn't use any like additional AI model to evaluate the responses from our um, like the LLMs from our list. I know that this is called something like LLM judge or something like that, but we didn't use that approach. Those evaluation was done by like our QA team only, like human beings only. Though we used another LLMs to generate some prompts, some testing data for us, because we needed a quite solid testing data. Like we needed as much prompts as possible. So we asked the AI to generate some prompts for us to be used for our evaluation.
Got it. So mainly human evaluations. No AI model automation at the present time. I guess
No.
that may be planned for the future.
Um, Maybe. Well, I'm not quite aware of the future plans, but I know that all this LLM integration activities are in active phase, and I guess that it will be like this process will be improving and including some automation aspects to testing and evaluation of even the selected LLM already and integrated LLM,
Sure.
because we need to evaluate it continuously, because LLMs evolve, they change, there are new risks introduced and so on and so forth. So we need
Yeah.
to just to track if it doesn't deteriorate. So I
Yeah.
guess some automation will be introduced, but
In
as far
some
as I know.
parts of the world, they have a saying about a snake eating its own tail. And sometimes I feel like that is what AI testing AI is doing.
Yeah, because uh, AI is smart. Some of the LLMs are rather smart, but human beings, they have this uh, nuances, feeling, the tone and so on and so forth, which AI still kind of lacks. But still, maybe they can be used for some linguistic patterns comparison, something like that, for keywords comparison.
So along those lines, and this one's from an anonymous attendee, are you tracking specific metrics related to the model after it's been deployed and is being used in production? Um, how do you know whether the AI that is now in production is failing or is producing bad outputs?
Yes. As for our product, we constantly checking the end-to-end functional flow, including this generation of content by the LLM for us, for our feature. And but we currently we have a kind of a set of prompts that we send each time to check the responses from LLM, and so we record them and can kind of compare the answers. Also, we constantly check language handling, because our product supports several languages, so it's important for us. So we have also a set of prompts in non-English languages, which we execute regularly. Also, some restricted content, certain prompts with the restricted content are sent to the LLM, which we expect to be banned, or which we expect to get the error for this restricted content. And for example, if we do not get the error for those feeds, we know know that something is like wrong, that we need to maybe report an incident and so.
Got it.
Yeah.
Here's another audience question from Dylan Shields. So, what standards do you use for testing unexpected or undesirable AI outputs? For example, if someone were to ask the AI, how do I build a bomb? What metrics would define an acceptable response?
Well, we didn't define like clear metrics for us, but um, uh, we checked certain security aspects. Also checked that the injections are handled correctly. Also checked, including this some a kind of dangerous content, including like bombs or terroristic acts, content handling, and so on and so forth. But those were like a set of prompts with the prohibited content, not metrics-based prompts.
Got it. So you kind of tested against a requirement that the model shouldn't output that kind of content. Is that right?
Well,
Yes.
it should either ban this content that is to return an error to such input, or it should a kind of maybe incorporate it into its content by into its generated content by saying that this is prohibited.
Got it.
Yeah, I actually had such case when testing a very similar input about bomb making, and this input was banned all the time. And at my numerous attempts to feed it, I got finally content generated. So I saw that I have caught an issue, but it was actually like telling me log into the application, go there, go do this, and in the end, like the homemade bomb shouldn't be like made, and you will not find the instructions or something like that.
Nice.
So it handled this content properly in this case.
And very humorously in this case. How many attempts did you have to make to get it to produce ultimately a kind of sarcastic or humorous response like that?
Well, I think it doesn't depend much on the attempts, but also on the context you provide with such input. Because if you just say, "Give me the instructions how to make a bomb," it most probably it will ban this input. But if you give some context like, I need to check that, for example, I will not find the instructions for making a bomb when I search something in my product's search functionality. So most probably it will try to generate some response to you,
Got it.
but not the instructions for sure. If you got the instructions generated, that's like a safety, uh, like a risky behavior from LLM.
So you have to be like quite sneaky, I guess, to prompt that kind of
Yes,
response from the model. Got it.
Yes, yes.
All right, I'm going to circle back round to a couple of my questions now. So one of the things I wanted to kind of understand from you, I mean, I think based on what you've been talking about so far, there were kind of a couple of different sort of phases to your AI testing, if I'm understanding correctly. One of which was like directly focused on the model itself and evaluating the models in this case and kind of using some of those evaluations to select a preferred model ultimately to then be integrated in a product. So I'm curious as to whether once the model that that the team had selected was integrated into the product, whether your testing had to change at that point, the approach to your testing, or did it stay kind of the same?
Well, it certainly it changed because now we had like the two aspects to be tested. We still evaluated the uh, let's say not only the responses but overall the behavior of the LLM as well. We still evaluated the LLMs, and we started testing. We started testing this feature also at the product level. That is, we started testing also the user experience with this feature. That is, for example, if the LLM fails, if the user will get a proper error which is comprehensible enough and will tell the user what should be changed in the prompt. As for example, as in case of restricted content, not just banning a user from generating a content, but also get the explanation what should be changed, what is not proper there. Yeah, so now we had like two dimensions of testing. LLM dimension left and product dimension entered also.
Got it. Um, looking back over your recent AI testing experiences, is there anything that you would do differently next time? Anything that you'd change about how you approached your testing?
Uh, yes, I think that we would start language handling evaluation earlier because as it appeared, we've obtained some issues after the product the LLM was integrated in the product. So this could be revealed earlier and also handled earlier, and devs would have more time to fix all those issues because there were like not one but several issues related to this language handling. So language handling, and also we would start, I guess, security or better say restricted content testing earlier as well. Because it's quite an important aspect. And at our evaluation stage, we mainly concentrated on the quality of the generated content, but stability and safety also are very important.
Of course. Yeah, absolutely. All right. And just final question from me, Natalia. Um, any any specific lessons or insights that you would want to share with other QA teams that are just starting out with AI testing and evaluations?
Uh, the lessons, let's say, first of all, I would advise to define a framework early, just to have the reliable results of the evaluation. Also to get a large testing basis that is as much as possible, and as much as various as possible prompts for testing the LLM, well, relevant to your product, because they can differ from product to product. Also, I would advise to switch. It was a bit hard personally for me to switch from deterministic mode to probabilistic mode. That is, we always, as a case, we always decide like, or here pass or fail, and here we need like to be more flexible in our activities, and also of course to keep your product and your users in mind, always in mind their needs. Just try to put yourself on in their place, and to think which outcome will be the best for them.
Got it. Thank you so much, Nataliia, for sharing those insights with us all. Hopefully everyone can see how, what you've been talking about sort of maps to some of the stuff I talked about at the beginning of the webinar. I wanted to kind of finish up with a few sort of bonus slides. So, one of the things that Nataliia kind of closed out with is the sort of shift from deterministic to more sort of probabilistic testing. And, obviously here at Testmo, we want to kind of support testers with that. So the first couple of articles that I talked about in our series was sort of geared towards exploring the kind of problem space. And then ultimately we wanted to kind of cap the series off with a guide as to how you can make that shift from sort of deterministic to more sort of probabilistic testing by using evaluations, and how evaluations, or evals as they're known in the sort of AI space, can actually be implemented in Testmo itself, with a view towards, kind of making your evaluations more robust, repeatable, and something that you can easily report on. So Kevin Rutkowski asked in the chat, did you track this information on a spreadsheet or in a system like Jira? Obviously, you can do that, but we'd recommend that you do so in Testmo itself to make your evaluations, as I said, robust, repeatable, and reportable. So, as we've already talked about a bit with Nataliia, an eval is a structured evaluation. It's used to measure the quality of AI outputs across defined dimensions. So you can think of evals as a test case of sorts, a test case for AI systems, but instead of pass, fail, deterministic outcomes, we capture scores, notes, context, probabilistic outcomes, measurements. And similar to what Nataliia covered earlier, you can use evals to cover, to measure things like accuracy, completeness, readability, factual precision, perhaps, other measurements that you may identify and that are useful in the context of your testing, allowing you to capture nuance, right? So not simple pass fail outcomes, but nuanced results that more simplistic assertions might miss. Build trust internally by showing how you actually measured the quality of your AI systems, and feed those insights back to your developers, informing things like, model tuning decisions or prompt improvements. So AI testing in a nutshell, measuring judgments, and capturing those measurements kind of systematically. How might you go about doing that in Testmo? Well, this is something that I spoke to in the sort of closing article. Breaking down the components of an evaluation, you can kind of model them as test case templates, right? And use Testmo as your source of truth for them, saving your team from using, spreadsheets or other less scalable methods, right? And each template is going to include things like your input type, what your evaluation criteria are. So again, those things like accuracy, completeness, readability, the dimensions or measurements of your evaluation. You may have some ideas about what you expect the output to actually look like based on your inputs. And you will almost certainly have some kind of AI output that you want to measure, and you may want to capture in a place where you can refer to it going forward. So, these are things that you can set up pretty easily inside a Testmo. You can use them in your projects, recording results, scores, notes, all of that kind of stuff as you would do in any test run. Ultimately in a structured, traceable, repeatable fashion, right? So, no spreadsheets falling apart as you fill them up with columns and results. Use a testing system that's dedicated to that purpose instead. That structure helps you bring clarity and repeatability to your AI testing, your evaluations, giving you, ultimately a single source of truth, consistency in your testing approach, traceability. You can trace your evals to requirements and defects. You can report on them, monitoring for trends over time or between different models using things like configurations. And you can also integrate these with the rest of your test management workflow, and your test automation as well. Ultimately, making every evaluation part of your testing story, not just like a one-off experiment. So just wanted to add those few sort of additional slides in there. As I've mentioned throughout the webinar, you can read more in our article series on the Testmo blog. So there's the path to that if you want to go away and read up some more. We are more or less at time. So, thank you everybody for attending our webinar. I've been Simon Knight. Nataliia, once again, thank you very much for joining the webinar and sitting through all of the questions, and responding to them so wonderfully. Your insights have been hugely valuable to me, and I hope to our audience as well.
Thank you. I'm happy I joined. I joined.
Thank you so much, Nataliia. So just to kind of close out, we want to support everybody through their AI testing journeys. I've hopefully dropped a link, or Jao, who's working away in the background supporting the webinar, has dropped a link in the Zoom comments. If there is anything else we can do or build into our product to help with your AI testing, we'd love to know about that. Please feel free to respond to the survey with your thoughts. And if you'd like to jump on a quick call with me to discuss how we can further support your testing needs in Testmo, then leave your email in that survey as well. and I will reach out to you in the coming weeks. We are now at time, so thanks for spending this hour with us. Happy AI testing.